So yeah, my name is Steve Weatherwax. I've been with Siemens for about 30 years now, and I'm the product manager for 2D and 3D data translation. And today we're going to talk about the SolidWorks data migration tool. And again, I think I'm going to sit down here. It's a little bit easier for me to kind of run the controls here and talk about some of the things. But I don't know, I guess probably most everybody's seen the demo this morning that Dan Staples had done during his presentation. And I hope what we do today in this is kind of go through a little bit more in detail about what's going on and how to use this tool, and maybe you understand a little bit more about it, be able to help yourself solve problems and those kind of things. So that's kind of where we're going with that. So what we're going to do, and this is just roughly the summary of things that we're going to go over. We'll talk about what this tool is, what's the requirements for using it, what the UI looks like, and what all the parameters do and those kind of things, and what this tool really does support. And then we'll take a look at some of the data that we've migrated and what it looks like and works and what it looks like in SolidEdge. So, all right, so this migration tool. So basically what it is it's using the SolidWorks automation layer or their APIs to bring up a file, to extract data from that file, and we put that into an XML file format. And this file format that we used was developed by Siemens. It's got a little bit of a twist to it. It's called PLM XML. Okay, it's kind of a structure that we created with our schema files so that we know where to put the data and then how to extract it on the SolidEdge side. So what we do is we bring up SolidWorks, we go into, say, the part, and we'll get the thread information, perhaps the material information, or in assemblies, and get the assembly constraints and those kind of things, and we'll put them in the XML format. And then we get an XML file, and this PLM XML file actually references the XT file, the Parasolid file, to get the geometry. So we take that file, write it to disk, and then we open up a SolidEdge draft file, read the PLM XML, which brings in the geometry and attributes the file, and then creates that part or assembly file. Okay, and so let's go a little bit forward here now. So some of the requirements are that you have to have a SolidEdge Premium, Classic, or Foundation package of SolidEdge. And the reason for that is we have to have access to the automation layer of SolidEdge as well. Now, in ST9, let me tell you a little bit of history about this migration tool. We started this migration tool back in ST6. And in ST6, we actually brought over parts and assembly files, okay, with a little bit of extra things. And we'll talk about what those things are in a little bit. And then again, in ST9, what we did is we started creating associative drawing views in ST9, which has just been released here in June. So you have to have a licensed copy of SolidWorks, and it has to be version 2012 or greater. Now, to get parts and assemblies over, 2012 is going to work fine for you. If you're trying to get associative drawings, what we found is that with 2014, 15, or 16, the migration goes a lot smoother and the results are a lot better. So as the years go by, the APIs on the SolidWorks side also got stronger, okay? So we get more data back instead of losing results and those kind of things. So with, say, 14, 15, or 16, it's a pretty solid migration of drawings, okay? So now, both applications must be installed on the same machine. Now this is a new requirement. Before ST9, or including ST9, you used to be able to take SolidWorks, put it somewhere on the network, and put SolidEdge on a different machine. And then we would communicate through the network and do this migration. And what we found over the past couple of years is that we started to regress in that area. In other words, that we would lose connection with the SolidWorks machine, and these functions that we're using are really, not things that SolidEdge developed. They're kind of Microsoft-ish things, operating system tools, things that we don't have control of. So starting in ST10, we're going to have a requirement that both of these applications, SolidEdge and SolidWorks, must be on the same machine. So I think it's a lot more robust, if you will, if you have them on the same machine, even in ST9. So I would suggest, highly suggest, that in ST9, if you're going to use this tool, put both applications on the same machine. Okay, so you can have your SolidWorks files in a share, where they can be on the local machine. The key point here is that the SolidWorks application must be able to resolve all the links. We're going to make a call to SolidWorks and say, open this file. He needs to be able to go out and find all the components of that assembly. If he can't find them, we can't get the data from him. So SolidWorks itself needs to resolve all those links. So this migration tool is supported in either the ordered environment or the synchronous environment. I can tell you that the synchronous environment is a better choice because then once you get the model in, you'll be able to manipulate it with synchronous type commands. We're not building a feature tree of the parts. We're just simply taking a solid model, a part copy if you will, and placing it in the part file. So all your synchronous commands would be able to then manipulate that body. We find the holes and those kind of things in synchronous. So how do you start this command? So if you go to the All Programs, Solid Edge, ST9, there's this data migration folder there. If you expand that, you would see that there's two things here to take note of. One is getting started. If you select getting started, it's going to open up the help files and take you right to the migration tool. And then you can kind of scroll through that whole thing and kind of review all the things that I'm going to tell you actually today. So it's the help topics for all the migration tools and all the data that what's supported, what's not supported, etc. should be in this list right here. And then there's the executable itself. So if you select the SolidWorks data migration, it's going to fire up the interface then to allow you to migrate files. And that UI looks like this. The very first field there is the host name. Where is this, the machine that has SolidWorks on it? Well, obviously in ST10 we won't need that field anymore, so there'll be a little bit of UI changes there. But right now you can have it on two different machines, so you can specify the machine where it's at. And then you have the SolidWorks working folder. And that's the folder in which we find all the SolidWorks files. Okay, so from that folder right there, we're going to present you a list of all the files in that folder. And those are the files that you can migrate. Now again, you could have a top-level assembly file in that folder, and as long as SolidWorks can resolve all the links, then the part files can be in any other folder on the system. Again, but SolidWorks has to resolve those links. And then you have a Solid Edge folder, and the Solid Edge folder is really the target location of where we're going to migrate the files to. So this is the folder in which we create all the Solid Edge files. And then of course you have template files, and template files are your choice. We default to what we deliver with Solid Edge, and you can modify those and point to your own template files. And then we have a configuration file. And the configuration file is basically these INI files that we use with all our data translators. And inside that INI, we're going to store all these parameters or settings that you make here, so that the next time you come through here, it's all filled out for you. Okay? And then we have log files. There's a log file in the SolidWorks folder, and then we also create a log file in the Solid Edge folder. So the log file in the SolidWorks folder is going to tell you all the gets that we're doing from the SolidWorks. Okay, we went off and we got the material. The material name is this. We found n number of holes. We found n number of relationships on the SolidWorks assembly, or things like that. So you can kind of see what information we're able to get and what information we didn't get. And then on the Solid Edge side, you would see where we created, or found the material in the Solid Edge material file. We found n number of holes in there, so we created those. Or maybe it says that I couldn't open this file and I didn't get anything. At least then you would know why it failed right there. So it's kind of a tracking device as to what happened and what was the result of that. So it's a good way to track through this thing to see where if you're trying to debug a problem, maybe a file didn't get translated and trying to figure out which file didn't get translated. Okay? All right, so this is the next dialog that comes up, and on the left-hand side is that list of all the files that we found in the SolidWorks folder. And the idea here is to take the folders that you want to migrate, move them from the left-hand side to the right-hand side. And you can do that by saying add all, which would take everything from the left, put it on the right. And by the way, this is parts, assemblies, and drawing files that are in this list right here. And then, or you could do a shift select, if you will. You can select individual files or shift select and get a range of files. And then you could say add those by hitting the add button, and it'll add anything that's selected there. So once the things are on the right-hand side, that would be the list that we're going to migrate. Now, to do your drawings, you're going to have to migrate all the parts and assembly files before you can do your drawing files. In other words, if you're just pointing to a folder here of nothing but draft files, those parts and assemblies must be on the other machine where we can find them to hook those links up, okay? And in this particular case that I'm showing you here, I have parts, assemblies, and drawings all in the same folder. If they're all in the same folder, you select them all. What we will do internally is sort through and get all the assemblies first, migrate them. We'll migrate all the parts. If the parts are used in an assembly, then we won't migrate them a second time, but we'll build the part and assembly files first, and then we'll do the drawing files. So for every drawing file, we'll look to see if we have that part or assembly based on the links that are there, and then we'll hook up the links for you. And then finally, the last page is to save the changes that you made to the INI or configuration file, and select the Finish button. And the Finish button will start the process of migrating files. All right, so what's supported? The first thing that we do is I was mentioned earlier, is that we support the material definition. So we go to the SolidWorks file, see if there's any material attached to the SolidWorks file. If it is, then we'll get the name of that material, and when we bring it over to Solid Edge, we try to match the name of that material to the name that's in the Solid Edge material file. If that name's not found, we won't hook up the material. So to make this more successful, we provide you a little utility, this swmat2sc mat.exe. And basically what that does is it takes the SolidWorks material file, their SLD MAT file, and converts that to a Solid Edge MTL file. That will ensure that, that when we find the SolidWorks piece of material definition, that we'll find it in our material file, and we'll hook it up, and you'll have all the properties of that material as well. Whole definitions are similar. We're going to get what is called in SolidWorks the call-out name. That may be something like 8mx by 1.5. Maybe that's the call-out string, okay? So we're going to be looking for that string in our Solid Edge holes table. If we don't find it, then we don't hook up the whole file, or this threaded hole. So what we're doing is we're looking for the threaded holes here to try to put that all together so that you maintain the threads on the Solid Edge side. So again, there's an executable here that will take their hole table and convert it to our hole table. And that kind of assure you that we'll always find the holes that were defined in SolidWorks, that they're defined in Solid Edge as well. And then we talk about assembly relationships. Now, Solid Edge and SolidWorks both have a very long list of relationships that are supported. For this migration tool, what we support are planar alignments, including offset, planar mates, including the offset, axial align, and grounded constraints. If it's not one of these, then we bring it over without any constraints. In other words, we don't ground that body once we get it into the assembly. I also might have mentioned that the first two relationships of jet, mates, and lines are face-based only. In SolidWorks, you're able to connect or mate based on the edges of two faces. Okay, so if it's edge-based, we won't hook that up in Solid Edge. We have to have the face ID itself to be able to bring that across and preserve that relationship. Now, for axial lines, we do a little bit of magic. If it's an edge of a circle, we can figure out that that's a cylinder, and we'll go get that cylinder ID and we'll hook all that up for you. But for mates and planar lines, we have to have the face-to-face relationships. If there is a family assembly or a configuration in the SolidWorks file, we'll bring that over as a family assembly in Solid Edge, and as well as alternate or flexible assemblies defined in SolidWorks, we'll bring those over as FOA members as well. So associative drawings, which is brand new in ST9, I told you a little bit about how we have this PLM XML file and how it references XT geometry and how we write that to disk and read that into SolidWorks. And I guess that's a lot to chew on, but it's really a little bit simpler than that. But we do something very similar on the drawing side of things. And on the drawing side, basically what we do is get the information from SolidWorks, the drawing view information, what's the center of it, what's the size of the view, what layers are on, what layers are off, etc. And we bring that over to, we put that in an XML file, and we get an AutoCAD DXF file that contains the geometry and text. And what we do is we read that DXF file into Solid Edge, we go to the XML file and construct the drawing views, which will overlay the DXF geometry, and then for every element that's overlaid, we remove the AutoCAD geometry from it. So the result is that you should have a drawing view without the DXF geometry behind it. And that way there, the tables and other things that we don't support are all preserved in the Solid Edge draft file, and we won't lose any information. Okay? So that's kind of how all that works. Excuse me. So, all the SolidWorks drawing view types are supported. Cutting planes, auxiliary view planes, detail envelopes, those are all supported. Dimensions are migrated from the SolidWorks and are bound to the rendered geometry in the drawing view. So basically the dimensions actually come over as part of the AutoCAD translation. And once the drawing view is created, then we go reparent those dimensions to the drawing view geometry. Okay, so there's a lot of things going on in the Solid Edge document there. So center marks are supported, hatches are supported. We also do the shaded views. If the view is shaded in AutoCAD, or excuse me, in SolidWorks, it would be shaded in Solid Edge. And of course, we support multi-sheet drawings. So maybe what we should do is take a little look at that.
Are the views still associated back to models?
Yes, yes. We're going to take a look at some of those drawings here in just a second. All right, so this is a model that we put together in SolidWorks. It's a fairly simple model. It has just two configurations. One is with the cover and all the bolts that hold this thing together. And then I went into this file and I suppressed the geometry that's missing now, and that's a configuration with SolidWorks. So all this geometry that's missing here is suppressed data in the SolidWorks model. So you can see the guys that are suppressed here that are dimmed out or dithered. So you can, excuse me, turn it on, turn it off, etc., right? So just looking at some of these cases here, I can open up, say, this input shaft here. I can look at some of these guys and show you that they do have some mates and axial alignments that are defined in this file. If you look at, for instance, this roller bearing and open it up, you see that we have a definition right here. So if you edit the material in Works, you can see that we're hooked up to some piece of material here. I was going to go back to that shaft as well. So. So in this file here, you can see we have some tapped holes here, both on where this bearing retainer is, and plus the other side of this thing where that cover was. There. And then we also have drawings of this file, and so the file is pretty simple. It has some dimensions on it, it has some text, it of course has the title block, has a shaded view, it has a little bit of hatch. We also have one of that input shaft as well. It has a shaded view, plus it has this guy here, all dimension. All these are drawing views themselves, so if you move them around, everything moves with it. If you modify this part here in SolidWorks, obviously the drawing view will update as well. So I'm not going to migrate these because it's going to roughly take 3 or 4 minutes to do that. So what I've done is I've migrated this file, and I would kind of like to go through the results and see what you end up with Solid Edge. So we started with this assembly, and here we have the FOAs. So we had the guy with cover and without cover. So we preserved that. We had, let me see, excuse me. Yeah, here's these tabs that you've probably seen this morning with the document tabs is what we call them. So I'll come over here to the input shaft again. In this input shaft, we look at this guy here. And obviously you can see that we have mates and axial lines here still. The shaft itself has the bearings hooked to it, and etc. And let's see, go back to this roller bearing because I believe open it up, and I believe it had the material definition in it. So this came over from, came over from SolidWorks. I had migrated that material definition file over, so it found the material definition and hooked it all up. And then we had the gearbox itself, we had the drawings. And let's
just hover over this link and then we'll go over.
We have a Solid Edge user here. Thank you. So I also wanted to take this gearbox, house and open it up too. And here you can see that we preserved the holes. So the threaded hole definition came about as well. So if you went in and grabbed one of these guys, you would see that you could modify the thread itself, right? So if I wanted to change from an M16, whatever, all the applicable holes would come up there. So the threads were all preserved there as well.
They were created from a pattern, does it bring that over too?
No, it won't bring the patterns over. Matter of fact, if you have a pattern or a mirror in SolidWorks, we'll bring those over as individual. We'll just place them in the assembly multiple times, but we'll reference only one file on disk, okay? So it's not like we create multiple files there. We'll keep your BOM correct, but inside of Solid Edge, we're going to add a part file for each one. And then you have the input shaft that we were looking at earlier. We move this guy back and forth. You see that it's also stiff now. You can perhaps double click on the view, brings it back to the part file. It's in synchronous for this one, so maybe you make that longer, and maybe you change that to something here. You go back to the input shaft drawing and do an update view. You see that the drawing itself changed. You might have to tidy some things up, but
Notice you didn't have to save your model, set.
yeah, I was actually surprised with that too, because I thought you would have had to save the model as well when I was preparing for this demo. I'm not sure if that's was meant to be or what, but
It's just the way it works.
I didn't question it. It seemed like it was
You
a
don't
pretty
say
good
long.
deal.
In this product or in?
It's all edge at all. You never have had to update the drawing. As long as it's in active memory, it's good.
Maybe that's what it was, is
Okay.
having both of them up at the
You know
same
what I'm
time then. And then we also have the gearbox as well. And I'm going to show you a little bit of dirt just so that you understand that this wasn't just a demo here, okay? So I told you earlier where we take the AutoCAD drawing and then we overlay this, we overlay the drawing view on it, and then we remove the AutoCAD geometry. Sometimes we're having problems at finding all that geometry, and you can see here that I left the boundaries to the hatch here. Well, those should have been removed as well. So you're going to see little things like that, and of course, it's not like it's a big deal. I mean, you can clean up your drawings pretty easy and put it back together, and you can use your drawing view alignment tools to make sure that everything's still aligned. But the way we're doing it, we're not losing any data. We don't bring over tables that might have been defined in words, okay? We bring those over as text. They're going through the AutoCAD translation. When SolidWorks saves those out, just like Solid Edge does. We take those tables, since AutoCAD doesn't have, AutoCAD does have a table object, but neither CAD system, SolidWorks or Solid Edge, take advantage of that. So SolidWorks writes it out as text and lines, and Solid Edge reads it in as text and lines. So if you wanted to hook up a whole table or something like that, you would have to delete that geometry and reconstruct that. So there's several things that you might have to do, but I think that this is really a very good tool, and I kind of wanted to go over just one more slide that I had here and talk about that. Okay, so I think this is a great tool. I think it will save you a tremendous amount of time in bringing your drawings over. But your mileage is going to vary. It's going to depend on how complex your parts are. The performance may not be as good as what you like because we're doing an awful lot of work there. Very complicated parts are certainly going to take longer. But us using the APIs and going and getting information and then rebuilding things in Solid Edge is time consuming. Now, I would suggest you start slow, okay? Don't be like this guy here and go down the road at 100 miles an hour here, because I think the way it works best is if you start with something boxy, something very simple, have a threaded hole, make sure that your threads are coming over, have a material definition, and have a drawing of this simple little box. Make that work first. Once you get that going, then work yourself into small assemblies and then into larger assemblies. I think you'd be much better off. And what you'll do in that process is you'll acquire the proper expectations. If you set your expectations way up here, we're never going to meet them. This is a data translator, and as Ricky Black will tell you, that you can't take apples and turn them into oranges, okay? Apples are going to be apples. Okay, so you have to understand that there's a difference in the structures between the two CAD systems, and set your expectations accordingly. But I think you'd be very happy with what we do have as far as getting you going. You know, we had, since ST6, I was saying we could migrate the parts and assemblies over, and there were a few people in the world that tried it. Now that drawings are coming across, everybody wants to try this tool. So the ability to get drawings is huge in the minds of a lot of people around the world. So give it a try and see how it works for you. I'm here to answer questions. Does anybody have any? Sure.
So can you talk a little more about your log files? That you said that you would look for constraints, and if they applied, or you couldn't reapply them in Solid Edge, you wouldn't. Are there any records of that type of stuff? There were
Yeah,
thread
sure.
holes, and in Edge there weren't thread holes.
Let me get out of here. So yeah, if you start looking through here, can you see that up there on the screen, or is it hard to read there? I can read probably some of this for you, but it says total number of SolidWorks configurations 1. So in this part file, we only found, it's not an FOP, we only found 1 configuration. By the way, if it was an FOP, we do not create FOPs in Solid Edge. What we do create in Solid Edge is each one of the individual part files that SolidWorks had, okay? Because remember, when you're in Solid Edge and you're making an FOP, you're suppressing features within there, and we're not bringing features over, we're bringing a solid body over. So we're not able to create the FOP there, but we will construct each one of the files. And if the assembly is using a different member, or more than one member, then we'll reference the correct member. So it says how many features were in the file, how many threads it found. You have to go to an assembly to find the assembly stuff. That might be in the other file.
So we're looking at this.
Yeah, so this is the log file on the SolidWorks log file where the SolidWorks data was put.
And the other one's solid.
Yeah, so, yeah, the information's in there, I can't find it live, I'm not a demo jock, I guess, right?
Did you do a compare on the 2 files? Did you do it like a compare on the 2 files and see discrepancies?
I don't think so, because they're totally 2 different pieces of information between the 2 files. Typically, what I look for is error, is a keyword that I look for to search these files when I'm looking for something that's missing. But, you know, I guess the reason I told you the process was so that obviously you have a copy of SolidWorks, you know what the process is. The quickest result or resolution is to look at the SolidWorks file, see what was in it, and see what Solid Edge provided. But this log file will tell you which files you need to look at.
In Solid Edge now, isn't there something we can compare 2 drawings?
Yes, there's a drawing compared tool.
So we couldn't compare the works draft and the Solid Edge draft.
That's doing more of a bitmap compare, not a text compare.
Let me tell you a little bit about data translation. Once you do a data translation on any data, that's no longer a released part, assembly, or drawing file, okay? Before you send it back to the shop, you need to go over and take a good look at them. I mean, in my mind, if we're 99% correct, that was a good data translation, okay? And if you have to go in and pretty it up by moving some things around or rearranging something, then you know, you'll have to touch the file, but it was still a successful translation in my mind. Maybe I don't set my expectations high enough, but 99% is up there. You know, if you'd have asked me 5 years ago, I'd have told you 80% was passing, so I moved the bar up myself, okay? Does anybody else have that? Yes, sir.
If they have custom file properties in the SolidWorks, does it transfer anything like that?
If they're custom file properties, yes, we will translate those as well. But you know, in SolidWorks, you can have properties within the features as well, and we don't get those. Like in a config, you can have descriptions and those things. And what we do for the configurations, when we bring those over, the FOA members, is we actually use the name, the file name, and the name of the member itself, and we concatenate those together.
I know in Solid Edge, we made a pretty substantial material table.
Mm-hmm.
And so if somebody send that in Works, and if they give that to us, can we upload that?
Yeah, I think what you want to do is just put it in the same folder as Solid Edge. You know, in Solid Edge, I don't remember where we did that, in ST7, ST6, wherever we have a preference / material folder, and the material file is an XLS file. That's what the SolidWorks file ends up, and if you put multiple files in that folder, then we'll find the SolidWorks material definition. We'll rip through all the XLS files in that folder looking for it. That way there you don't have to cross-contaminate here. Yes, sir.
So on the, like the title block stuff that grabs off the SolidWorks, does it try and put anything onto a background sheet in SolidEdge, or does it just put everything?
No, it's gonna put everything on the foreground sheet then too. Yeah, it's just like it's an AutoCAD translation. I don't know if you, I think everybody's probably done an AutoCAD translation, right? Yeah, you have to keep that in mind that we're using that translator to do these things, and that will kind of give you an idea of what results, you know, again, that's gonna set your expectations, right? Yes, sir.
How does it handle, or how does it handle display states of parts and so on?
Yeah, that's very good. It's a very good question. We don't get display states because display states in SolidEdge are found in our true configuration files, right? So if you use display states in SolidWorks, what we do is we bring those part files over, and if the display state in SolidWorks assembly is off, we turn it on in SolidEdge. In other words, just because the display state is off doesn't mean that we're going to ignore the file. It is still part of that assembly.
Right, I'm thinking more in drawings where I have.
Where you've referenced display states?
Multiple display states.
Yeah, that is a whole.
And how ugly that's gonna look.
And, you know, and I didn't realize that was happening until just a few weeks ago. So we're kind of rethinking what we need to do there. What it was is I had a multi-sheet drawing file, and it was of an assembly, and the assembly had like 5 different display states, and we were getting the active display state, and that's what we're displaying on each of the drawing views, so the whole thing was just completely, totally wrong. And I think the shortcut to solve that problem today is to say, one is to take display states and convert those to our configuration file. And the other solution, a quick solution, just so that we get the right data over, is recognize that there are display states, and if the drawing is referenced in those display states, then don't do the translation, or don't create the true drawing views and just end up with the AutoCAD translation. At least then you get the data over correctly. So that's kind of one of the, I think we're going to do the latter of that first while we regroup, I guess, because that configuration problem is a much more difficult problem to create that file. Yes, sir.
I think I ran into exactly what he's talking about. I just did a bunch of translations, and the SolidWorks file had, it was an assembly, and they would on some of the detail views, they would like flatten one piece of the assembly, but it was still within the assembly. So, you follow me? So when they converted it over to Edge draft, what you got was it showed all the parts within the assembly and the flat part. So you had to go back in.
Did I talk to you about that?
Yeah, I'm Brian.
Oh.
Man. So I don't know if we talked about that.
Yeah, we did. That was your file that I was just talking about. Because now that's exactly what happened.
So
Yeah, we're
you got
referencing
all
this.
of you got
Yeah.
every part within each view. You had to go back in the display and
Because
go
we,
you had to find out which parts it was. Because it was
Yeah,
all
and that's what I think we're gonna end up with. We do assembly drawings where you have to do stack ups, and then that stack up gets spread apart before you put it in other pieces. And
but don't
half the guys do display states and half the guys do configurations for whether or not those. So in the display state, if you're bringing over everything, you're gonna end up with like 4 of something if you only have 1 on it.
And I think the right thing for us to do immediately is to obviously log that problem, and then the solution, the quickest solution for us is to make the migrator fail in that instance and only give us the AutoCAD translation, and then, like I said, regroup when we can spend a little bit more time and think that problem through and do the correct thing there.
I mean, it translated right, but it just gave us too much. So,
Yeah.
But I was able to go into each view under the drawing, the display,
Correct.
and I could turn off the stuff that wasn't supposed to be there.
Yeah, let me tell you, in the last year or so, I've learned a lot more about SolidWorks than I ever wanted to know. Because it's problems like that, you know, somebody send you a problem, you look at it and you say, ah.
I just assume that display state is what they call it, work
Mhm.
on works guys.
It is, it's definitely
Where
what
they
it is.
isolate one part from that.
Yes, it's just like a configuration, except it's used turning parts on and off instead of doing a suppression on.
Yeah, mostly it's, if you do a configuration, you have to do it through mates and stuff like that, or if you just do display state, basically just tightening it.
Yeah.
So it doesn't break everything.
So I have a question about, you mentioned, if you select, let's say you had when they did a pack and go from guys that did the SolidWorks stuff and dumped it to us.
Yep.
You know, my example was they did it where they maintained the file folder structure, so I had the assemblies in one folder, and the parts in another folder, and the drawings in another folder.
Yeah.
And I had to go through the assemblies, and it would, because it could, those assemblies were good, it would resolve all the components that go in it,
Mhm.
recognize those. So, and even if you do it flat, you said, if you grab all the parts in the flattened folder, right, where everything's in there, and you select everything and say, migrate that.
Yeah.
It sorts through it and knows what's,
Yeah, well, what it does is it does all the assemblies first, and all the assemblies are gonna get all the part files, and then he's gonna hook all that stuff up, and then he's gonna go through the parts and say, oh, I've already done you, oh, I haven't done you, let me do you.
okay, well, let me ask you this.
Uh-huh.
So if, like, my example, I know what the top level assembly is.
Mhm.
If I only click that,
That's faster.
that's what I was like, is there less of is that the better way to do it?
Yeah, yes, much better, there's a lot less files that we're gonna process. So we still have to grab each file and look and see if it's part of that assembly, if it's not part of that assembly, is it migrated, is it in this folder, if it's not in this folder, then migrate it.
Okay,
So if you only want that assembly,
that's
then just do that assembly.
what I was.
And then go to your drafts and then do your drafts, and the drafts will hook up automatically if they're in that folder.
Most of that worked pretty well. I had a couple that it had to have been something I can't, I'm sure, but it was, some of them came over and there weren't any.
Obviously, Brian, I didn't do a very good job at setting your expectations.
No, I didn't know what to expect when I did it, so
Yeah.
they came out better than I thought.
Well, good.
Yeah, and you have to think too, this is our first shot at this,
Yeah.
and it's pretty good for
Yeah.
the first shot.
The one thing I didn't like, and I don't know if it's a SolidWorks thing, the way they translated, but
Mhm.
it's like wherever they had an ISO view of something, and it's like they embedded they had a title for it, for example.
Oh, yeah.
When you translate it into drafts,
Mhm.
that text is embedded in the part view. And it seemed to always write justify it. So it was like wherever your drawing view window was, in order to fix that text, to put it underneath the part, you know what I'm saying?
The caption.
Yeah,
You
go
went
into the
drawing
view and take it out.
Move it over and then get back out. And it was like, why is there text in a part view?
I don't understand why you're seeing what you're seeing, and I probably have to look at the file. But what might give you a better hand is to look at the AutoCAD file. You have a copy of AutoCAD.
I don't know if it's something that works, if it's something that works better.
Call me up next week and send me the file, and I'll take a look at it.
Okay.
You probably have my number, and if you don't, you do now, right? Okay. I guess we were talking the last few weeks. So anybody else have any questions there, or? Yes.
I'm not a SolidWorks person, but we recently acquired a company that does everything in
Mm-hmm.
SolidWorks. The main issue that they were having was with, I want to say the solid equivalent would be multi-body stuff, where you've got, several bodies with one SolidWorks file. How does that translate?
Well, that's gonna bring the files over to one, it's gonna create a multi-body solid edge part file as well. And they're gonna come over as one design body and a number of construction bodies. They're still multi-bodies, they're still solid bodies, they're just constructions themselves. You might have to go into the part file and toggle the constructions to solids, or excuse me, to design bodies. There's a switch and edge that if you right-click on a multi-body file, it'll let you toggle between construction and design. Okay, so design is the active body in which you're going to add features to. The constructions are just there to reference, but you can toggle any one of the constructions to be your active design body and add features to it. So you'd have to toggle all of them to design body. So. But all the data should come across. And maybe there's some work to do there to decide whether they are constructions or design bodies or not. We hadn't crossed that bridge either. Okay, I appreciate everybody coming. Thank you very much. And if you have any questions, my contact stuff's up here. Welcome to call me. I'll be glad to help you any way that I can.